This is the second help video for the pivot simulation. Why do we have seasons? It's for the second part, the reason for seasons. I'm actually going to go for the show split question view so that we can keep the simulation on the side while we scroll through the questions. So this first question talks about when each equinox and solstice is. If you don't know that, then you should go back to the lecture video for the energy from the sun content page, because we go over that in that video. And it should be in your notes. If you didn't take notes, then you didn't finish an assignment, so go back and do that before you do this assignment. But now here at number 2, notice that we're using the same simulation as in the first part. We can put the direction that the sun's solar radiation is hitting the earth. We can play and pause the earth revolving around the sun. We can stop the earth's rotation. Latitude change and light sensor really don't matter right now. They'll come into play later. It doesn't even do anything. But we do have top view and side views. So pay attention to what view you're on, because the simulation directions will tell you which one to be on. So for this one, it says to be on side view, which we are. And I want you to notice the difference between the direction that the earth is pointing at different times of the year. So actually, I'm going to go back to this so it's bigger for you. So let's observe this. June. We'll go right to where the solstice is, somewhere right here. So what you should do while you're looking at this is imagine where the equator is. Notice that the axis, North Pole is here, South Pole is here, so the Earth is on its tilt, right? 23.4 degrees, 23.4, 23.5. So the equator is like that. Now doing this, then we can check out the way that the light is hitting the Earth. We notice that all the places up here in the northern hemisphere, north of the equator, are getting more sunlight and more direct sunlight than in the southern hemisphere. So when you're using this simulation, keep in mind where the equator is and notice which way the Earth's axis is pointing. If we switch this and we go about 6 months later, December, remember, think about where that equator is. The equator is probably somewhere like here, roughly. And you can see that the southern hemisphere is getting more sunlight and more direct sunlight than the northern hemisphere. And if you look very closely, we can see that as it goes by, there's Australia, southern tip of Africa, South America, there's America. Asia, northern Africa, there's America. So we are in the northern hemisphere. We're getting, at this time of year, much less light and less direct light. All right. Just an extra reminder. Let me clear that. Number 3, it starts by saying click top view. Make sure you follow the directions. And you can spin this all around and do the same thing. All right. Read the directions carefully. One thing I would add, though, which I should have done in the lecture video, is in your notes from yesterday, I would add what the Tropic of Cancer and the Tropic of Capricorn are. These are very important. The Tropic of Cancer is at positive 23 degrees latitude. The Tropic of Capricorn is negative 23 degrees latitude, or southern, on the southern half of the Earth. These are places where the sunlight hits directly, the most direct spot, depending on what time of the year you're on. So in your notes, add that. During the winter, for us in the northern hemisphere, the most direct sun is hitting the Tropic of Capricorn. During the summer, we go 6 months later, the most direct sunlight is hitting here, which is considered the Tropic of Cancer. Add that to your notes.